So what we call the POSIX signal. This is a fast chapter. So why is it a fast chapter? I only touch some surface thing for you to play around. Okay? What is the thing that I want to play around with you? Although I don't have the code, I hope that by the end of this part, Control C, okay? By the end of this part, I can teach. Hope that today I can tell you what this program is about. What is this program? This program is, okay, if you know, then you will know what I'm typing. Okay, so out.h signal.h, okay, and what I'm going to do is I want to handle segmentation faults. Okay, and you know, this is the null pointer, right? Yeah, anyone don't know how it is a null pointer? Yeah, this week you can still drop this course, huh? What is the fate of this program? Segmentation fault, right? So I will teach you this. Segmentation what? All right. Oh, I forgot to include the stdlib.h. Okay. Compound. What? 0? Did I do anything wrong? Optimization. Optimization. Okay, so I have to compile it again. Optimization. GCC minus O test.c test. Yeah. Yeah. Originally, it should say segmentation faults. Now it says segmentation what? Yeah, this is what we are going to teach this in this part, okay? So this part is called POSIX signal. It's a system that we already see one example, the SIG chart, right? So what are signals? In CE, you will have a better picture in this area, okay? You know that every device generates signals, okay? We call it hardware signal. Hardware signal may be a keyboard, maybe a CPU. CPU will generate signal. Like you put in wrong code, it will give us segmentation faults. Hard disk also a signal telling that hey, the drop that you send to me, you want to get a 1K, 1 meg of data. I got it down, so tell you. And the procedure is not very transparent to you, right? You don't know because the kernel is two guys already handle all the things for you. Okay? So you don't know, except that you go to the C program, and C program usually will implement hardware by themselves. So you will know that we need special things to control the hardware. Now, let's say that you don't know. So we won't cover this in this course. We will mostly cover these two guys. What are the two guys, type 2 and type 3? Type 2 class of signal is generated directly from the kernel. You see one example already, SIG chart. SIG chart gives you a signal by running this kernel code. The kernel code thinks that, okay, it is exact time for it to terminate it. Give the parent process, let's say this is a parent process, signal. This is SIG chart. Next, type 3 of the signal, okay, by the way, POSIX, the definition is here, okay. Type 3 is a signal that generated from another process. What are the examples? You can use top or PS, appears. It's top only. It appears now. Top, you can use top to kill someone. You can use, I don't know, the Windows, what is that? Process manager, right? The process manager, when you want to kill some process, okay, let's say that in year 010, the Visual Studio stops, okay, it's like want to kill it, okay, and you launch another process, send a signal there, hey, you're going to die, okay? What can we do? Okay, we can I'll demonstrate another example. So the example is like this. I call it loop. Okay, don't care what I'm doing. Yeah, the one line while loop. You don't know what I'm typing. Okay, one line while loop. Okay, so I can have a while loop here. It's looping now. Okay, actually I can send a direct signal to this guy. I have to look up his PID first. Now, this is a long list. Okay, can you find loop here? No, you cannot find it. So I will use the grab command. Grab means search the output for the keyword called loop. So this is his PID. Okay, I just copied it. Kill that PID. Then this guy will say terminated. Again, kill. This guy will set, oops, oh, wrong PID, sorry. PID, oh, this is the PID. Kill, segmentation fault signal. Send to that process. That process will then says segmentation fault. Yeah, you can artificially generate segmentation fault. Yeah. You're running a program, okay? Your partner is testing a program. You silently use another terminal, send a segmentation fault to his process, and then, oh, what happened? And he will have 10 days of debugging without any reason. Okay? Yeah, segmentation fault signal. Okay? Of course, you have to be the same owner. Okay? You are the owner of that process, like T11 process. Okay? You can only use the T11 credential to send the T11 process over your administrator routes. Then you can send to other process. Okay? So the previous story is a fake story. Okay? You and your partner using different accounts unless you guys share account. Okay? Send a segmentation fault signal to him. Okay? Send a segmentation fault signal to his shell, to his running program, then it will be a disaster. Huh? Okay, so what exactly is a hardware signal? I can give you a preview over what is a hardware signal. The hardware signal is easy to understand. Actually, the thing happens during the system boot up. Okay? So when the system boot up, it's actually hard coding what we call a hardware interrupt routine. Okay? Or hardware signal handling routine, but usually we call it IR interrupt. Okay? Interrupt request. What is the queue? Or request is the queue. Hardware interrupt request. Okay, and this is hidden inside the CPU. Okay, and you actually see this hardware interrupt a lot. Okay, so what is this during the execution? Let's say you are originally running a user program, user space program in this area, execute a lot of cells. Okay, it suddenly sends something. Okay, we are beyond the first. Okay, so you generate a hardware interrupt from your keyboard, so as to interrupt the CPU. CPU originally running this guy. And you send a hardware signal through the motherboard to the CPU. The CPU will suddenly, boom, find that I've got a problem. What is the problem? The signal going through the motherboard will go to the CPU as destination. And here is a magnifying wheel of the CPU. There is what we call interrupt vectors. A set of function pointer, array of function pointer. We have number 1, number 2, number 3. Remember, someone correct me if I'm wrong. Number 1 is a timer, right? See guys, you here. See guys, you know what? Okay. Sorry, we don't have see guys here. The see guys, you know what? There's a hardware interrupt. Number 1, the array number 1 guy should be a timer. I remember the network card should be 9, right? What is GPU? GPU, I can't remember. GPU should be using other way. Okay? So our device is using occupying this array. Let's say the keyboard, I can't remember the keyboard number. Let's say keyboard number, I just read number 2, okay? Then you will go through this pointer and say that, hey, this 2 is actually mapping to the code inside the kernel like this location. Okay? Then you will execute that code, get the key from the keyboard, and put it in the kernel space memory so that you can ship that key to that process. Okay? So this is the hardware interrupt concept. Okay? Yeah, so this is just an animation. Let's say the keyboard interrupt comes in, and then I will trigger that function. And this model, we will adopt it in user program. User program, let's say in the previous case, I have a while loop, then I send the signal to that program. Let's say the signal is a QU. Okay? We will adopt this. Okay? What does it mean adopt this? You will receive that signal just like your CPU receive that signal, click start the routine, and the routine is a QU. Okay? So if you want to know the big picture of a signal inside hardware is like this. Okay, the big picture is I have a keyboard, I have a motherboard, and said that this signal eventually will go to the CPU. And let's say before this cycle happens, how about the software? The software is actually you are doing this simple task. You call scanf for a little. Is it a pair? Yeah, no pair. It's number, okay? For this little number, you ask the computer to give you that number. And actually, you will call scanf. Scanf will call read system call. Read system will find that, okay, let's check whether the kernel space memory has anything waiting for me. It says no. Okay? Nothing is waiting. Let's say that, oh, this guy is idle, so no input. Okay? Then what will happen? The process will put waiting if there's no pending character inside the kernel space memory. And now this is the half of the flow of the software. The hardware flow will just say that, okay, I click on my keyboard, generate I/O or hardware signal, fly to the CPU. CPU knows that, okay, that signal means that a particular routine inside the kernel. Okay? So this is the thing that we just know. Now, how about this routine? This routine is actually manipulating data inside the kernel. Put that character into a variable. And so happens that we know that there is a process waiting. We call it a forward process. A process in a forward. Waiting for my call. Waiting. So I put that character into the buffer of that scanf code. And that's all. Seems to be hard. One more before we stop. Okay? One more before we stop. When we look at it from the CPU point of view, okay, when we look at the CPU point of view, we have a big trouble. What is the trouble? Because for us, humans seldom work like a CPU. CPU, you can stop it, say interrupt, do some job, and come back. Human is not like that, right? Think about the case in your home. Your mother tells you to do something. You will immediately handle that. No, usually not. Okay? You put it in the queue. Okay? And usually it's in a stack. Okay? The mother father command goes to the bottom. Okay? Then you suddenly get Facebook command, Facebook intro comes. Switch it. Okay? Yeah, it doesn't do it like that. Okay? CPU handle it immediately. Okay? Let's say the previous code is like this. You're invoking scanf. So read system call. Go in here. Look at the kernel buffer. Kernel buffer find nothing. Wait. Then at that moment of time, we don't let the CPU idle. The CPU won't idle until you tap on the keyboard. So it will schedule another thing. So the scheduling another thing is the kernel test. Kernel pick this little light green guy, okay? And while this guy is calling, it can also call system call. It's called system call won't kickstart this guy because we are not looking for other system call to help me. I only look for a keyboard to help me to get out of this waiting help. So we will continue until suddenly interrupt comes. When interrupt comes, no matter what the CPU is doing, immediately switch to the hardware to get the things that you want, put it in the kernel memory. Now, after I put it in kernel memory, I'm running this phase, okay? When I reach this phase, so the kernel interrupt handling routine will finish. Now, this is the task for the kernel. Where the kernel put the data into this guy's buffer and let that guy run, or put the priority higher to be the guy that I just interrupt. It's up to the CPU. CPU can choose, okay, sorry, I just interrupt you, I let you run. It's okay. Or the CPU may think that, the kernel may think that, okay, I just find the data for you guy, this guy, so I put that memory into there and let you run immediately so that you can serve your client. This is not an issue. We can have both, okay? I just, because of PowerPoint, it's getting, I don't have too much space here, so I choose this, okay? So this is from a CPU point of view, okay? So I know that we have a big problem